Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, in this video, I would like to analyze the frame shown using moment distribution method. So we are going to calculate the member end moment or internal moment, and we also call it as bending moment for the frame. The frame is unsymmetrical frame due to geometry as well as loading. So this is a Sidesway frame. And since the frame is subjected to an applied moment at B of 350 kilonewton meter clockwise, and as well as this since the frame is unsymmetry, so there will be sidesway as well. So we are going to analyze this. To analyze this using moment distribution method, we have to divide the analysis into two parts. The first part is for table number one. The first part is actually for the no sidesway frame, the properly restrained frame, and the second part of analysis is for table number two. Table number two, we will analyze the frame due to sidesway. So we will start with the first part first. Okay, the first part is for table one, and this is for no sidesway frame. No sidesway frame. And of course we have another part, we call it as part number two. Part number two is for table number two. This is side sway frame. Okay, what is the difference between these two parts? Okay, the first part is we analyze no side sway frame. For no side sway frame, okay, by looking at the frame, the original frame, the frame will move to side sway. Okay, we assume that the frame is moving towards right direction. So for the no sidesway frame, it means that we have to put one imaginary pin here, and due to this there will be R here. Okay, so this is actually the diagram we analyze under part 1, no sidesway frame. This is properly restrained frame. This is actually diagram B. Okay, if we go back to the concept, we have diagram ABCD. ABC is actually we get from principle of superposition, and for part 1 we analyze diagram B, and for part 2 we analyze side sway frame, and for side sway frame we actually analyze diagram D. Diagram D is look like this. The same geometry of the frame, but this time it is subjected to R prime. So this is diagram D. So when we analyze when we do the first part, we analyze this diagram. We have to put one pin support at C, because the frame without this it move to right direction. So we have to put this pin and artificial support so that the frame become properly restrained. So for properly restrained, there is no side sway. So this is diagram that we analyze in part 1. And in part B, we analyze the same geometry of the frame, but this time the frame is subjected to R prime, not R, but R prime. Okay, the same geometry, there is no loading. So we just need to focus on the geometry of the frame, and we have to put uh, R prime. R prime in right direction, because at the beginning of this question we assume that the frame is moving towards right direction. So this is the two frame that we are going to analyze. Okay. Okay. So we will start table number one. Of course, we have to have stiffness factor and distribution factor, because we will use this distribution factor in the table for both table 1 and table 2. So the detail about the calculation of K as well as DF have been explained in previous video, 10 video for one frame question. Okay, so we just skip that one, and we just do table number one. Remember, table number one is for diagram B. Okay, for table number one, since there are three members, there are three members, so we will have, for three members, we will have 6 end moments. Start from AB until DC. Okay, so we have to list all the members. We have to list all the members. We have AB, BA, BC, CB, CD, and DC. And then K, we will determine K value in terms of EI here. Okay, so looking at this, the member length for AB is 4 meter. So it is EI, so 4 EI over 4. It is 4, the K, we use 4 EI over L, so the L is 4 meters, so it is 4 over 4. So this one is equivalent to 1. For ABBA is the same. Okay, when move to member BC, internal member, so we still use 4 EI over L, but this time we have to times by 2, because the EI is 2. So it is 4 times 2 divided by 6 for EI over L. So we get 1.333. 1.333 for K value. For K value. And for member CD it is 7.5. So for N is fixed. So we still use 4 EI over L. So it is 4 EI divided by 7.5. So we get 0.533. So this one is 0.533 and 0.533. Okay. And now we will calculate distribution factor. Now we calculate distribution factor. So distribution factor for N fixed A is 0. N fixed D is 0. Okay, now we want to calculate DF for BA. DF for BA is 1 divided by total 2.333. We get 0.429. 0.429. Okay, and another one will be 0.571. 0.571. Okay, and next for CB is 1.333 divided by 1.333 plus 0.533. It is 0.714 and 0.286. 0.286. Okay, so this is distribution factor. So we will use the same distribution factor for both tables. So we move directly to FEM. So this is table number one. So for FEM, okay, actually FEM we calculate based on member load. Means that UDL, which is subjected along the member, FEM also, FEM we can get from point load that is subjected at the center of the member, and FEM also we get from point load at anywhere on the member except at joint position. Okay, now looking at the diagram, for member AB there is no member load. For member BC, there is no member load. For CD, there is no member load. But we are given a moment and applied moment at joint B. So we have to go back to the concept where we have to understand that the moment that we distribute in the table is actually joint moment. So when we have fixed end moment, we distribute the moment. We distribute the moment. But now we are not given any fixed end moment that we can calculate, but what we have is joint moment. So that joint moment we have to distribute, because if we have fixed end moment, we have to change to joint moment. If we have FEM, we have to change to joint moment. The joint moment we distribute. Now, the FEM, there is no FEM, but we have joint moment. So, we have to distribute joint moment. Okay, we have to distribute joint moment means that we do not put the 150, the 350, the 350 in A or B, C, because it is one value. It is one value. So we just need to distribute the 150. Okay, so 150 is belong to joint B, so the value is 150. So this 150 we have to distribute to BA by times 150 times 0.429. It is negative 64.35, and 85.65. 85, we don't have to change, we don't have to change sign. 85.65, 85.65. Okay, we don't have to change sign. We change sign, because this is not FEM, this is joint moment. Okay, joint moment, this is J, this is joint moment. Okay, joint moment is 150. Okay, if we have moment, if we have fixed end moment, it is going to be like this. For example, we have UDL here. This UDL will give us this FEM, this FEM, and this FEM, and we have this, and let's say AB is has no load, so it's just zero here. So anyway, the moment that we distribute is not directly this, but we actually distribute join moment. Join moment, this is join. So this is B, this is also BC. Okay, but the moment that we distribute is joint moment. Joint moment is opposite with member and moment. Joint moment is opposite with member and moment, opposite. And this is the moment that we distribute. Okay, so in this case, we don't have this, and this, but we have moment at B, the value is 150. So this 150 we have to time with 0.429, and times also with 0.571. So the joint moment, when we distribute, we don't have to put negative. Okay, so we get 85.65 and 64.35. Okay, that's all. Then we have to carry over the value. Carry over the value. 64.35 divided by 2, 32.175. Okay, and 85.65 we divide by 2, we get 42825. 42.825. Okay, next we will continue as usual. So means that under carryover we get the new member and moment, and the member and moment we have to change sign. Okay, so we repeat, we continue as usual. Okay, so we have to distribute this 42. So we will get negative negative. So this 42, 42.8825 times by 0.714. So we get negative 30. 577. And another one is 42825. 12.248. 248. Okay, next we repeat the process. Carry over. Carry over. So negative 30.577 bahag 2 divided by 2. It is 15.289. And 12.248 divided by 2, we get 6.124. 6 negative 6.124. We will distribute again. Okay, so this one will be positive positive. So 15.289 times 0.429, it is 6.559. 289, 80, 8.773. 8.73. Then we have to carry over 6,559 divided by 2. 328. 3.27978. 3.28. 4365. 4365. 4365. Distribution. We will get negative negative for CB and CD. 4.365 times 0.714. 3117. 3117. 1.248. 248. Carry over. Carry over 3117 divided by 2. We get negative. Carry over negative. Positive. Positive. Negative. Carry over negative. 1559. 1559. You get 1.552. 2. Carry over distribution. Distribute again. So sorry, this one we should this not this 3.117 divided by 2, we get 1559, and then and it is negative. It is negative, and another one is negative also. 0.248 divided by 2, we get 0.624. 624. Okay, we continue with distribution. Distribution, it is 1.559 times 0.429. We get positive 0.669. 0.89. 0.89 carry over 0.669 divided by 2, 335. 445. Distribution. It is 0.445 times 0.714. It is negative 0.318. 127. 7 carry over. So we carry the value negative 0.318 divided by 2, 0.159. 0.127 divided by 2. Negative 0.064. 1, 2, 3, 4, 5, 6 carry over. So we will do the last distribution. Okay, 0.159 times 0.429. 429. So we get 0.06. 0.068. Negative, positive 0.091. That's all. So we have to stop at distribution, and the M, the end moment from table number 1. Table number 1 is, okay, we consider start from this first distribution. Until the last distribution. We don't need to include 150 because 150 is belong to joint B. Okay, so we total all this. We get 32175, 3.28, 0.335. 35. This is 35.79. Okay, next is 64.35 plus 6.559 plus 0.669 plus 0.068, 71.6646. And next is 85.65 minus 15.289 plus 8.73 minus 1.559 plus 0.89 minus 0.159 plus 0.091. So we get 78.354. And please take note that the total of these two, we will get 150. 71.646 plus 78.354, we get 150, representing this one. Okay, I use the 150, not 350. Okay, change this. 150. Okay, 150. So this is 150. Okay, So 42.825 minus 30.577 plus 4.365 minus 3.117 plus 0.445 minus 0.318. So we get this as 13.623. 13.623. And next is negative 12.248, negative 1.248, negative 0.127. We get back the same but opposite sign, 13.623. And BC is negative 6.124 minus 0.624 minus 0.064. So we get negative 6.813. Negative 6.813. Okay, so I have changed the moment at B equal to 150 because I have used 150 in the table. Doesn't matter. Okay, so this is the end moment. So we have to analyze this end moment. We have to have the free body diagram representing 35.79 is here, 35.79, and 71.646, 71.646. Then we have 78.354. Then we have 13. Then we have 13. So this is the value 7. This is 71.646 and 35.79, 35.79, 79. Okay, we get 78.354 and 13.623, not 8 but 623, and we get 13.623 and negative 6.812, negative 6.812. Okay, so we put the shear, the horizontal forces and vertical forces like this, and then we have this and this and this and this. Okay, so we label as V1 H1. So this is H1 V1, V2 H2, V2 H2, H2 V2, V1 H1. Okay, so we have this free body diagram which we get when we draw the member separately, and for each element it has internal forces to remain the system, the member in equilibrium. This is how we translate the member and moment that we get from the table. And from this, we will analyze the beam and column to get the value of actually AX and DX, or H1 and H2, in order to calculate the restraining force. Okay, so for the restraining force, the first step is we have to analyze this for the first step. The second step is this. The third step is this. Okay, so we have three steps. Okay, we have three steps. Why we are going to do this? Because we want to calculate R. So from the diagram, for diagram B, so we just need to label horizontal reaction and horizontal forces. Okay, so this is H1, this is H2, or AY dy. So from this we get shear equation. Shear equation for this is H1 minus H2 minus R is equal to 0. So R is H1 minus H2. H1 minus H2. This is for diagram B, H1 minus H2. So since here we need to have, in order to calculate H1, we have to have V1. We can get H2 directly, but we cannot get H1 directly. In order to get H1, we have to analyze member BC. We have to analyze member BC. BC. So that is why I have labeled the process as 1, 2, 3. Okay, so step number 1. Step number 1. Okay, step number 1, from static equilibrium. From static equilibrium, we get 78354. So by taking moment at C. Taking moment at C is equal to 0. So we get 78354. 78354 plus 13,623. 13,623. 13,623. And then it is 6 meter length. So it is 6 times V1. 6V1 is equal to 0. 6V1. So all positive. 6V1 also positive. Positive. So V1 we get negative. V1 we get negative 78.354 plus 14, 13.6, 13.623, and we divide by 6. By 6. It is 15, negative 15, negative 15.33 kilonewton. Okay, that is number 1. Number 2, we want to calculate H1. H1. H1, we analyze number 2. We analyze number 2. So it is negative plus plus the distance, the height is 7.5 plus 7.5 times H2. It is negative 13.623 minus 6812 plus 7.5 H2. This is equal to 0. It is negative. It is negative. It is positive 7.5 H2. Okay, so we will get 13.623 plus 6.812 divide by 7.5. So we get H2 is equal to positive 2.72 5 kilonewton. Okay, this is H2. So we move to step number 3. This one is step number 3. This one is step number 3. So number 3, the moment clockwise 3579 35.79 plus 71646 71646 71646 646, and of course we have to have this first. If this is 4 meter, this is 3 meter, 4 squared minus 3 squared square root 2.65. So this is 2.65, 2.65. So this is V1, this is H1. H1. So we get V1 plus V1 is negative 15.33, negative 15.33 V1 times 2.65. 2, it is 2.65. So we have to minus 3H1. Minus 3H1, this is equal to 0. So H1 is equal to 35.79 plus 71.646 minus 15.33 times 2.65. We divide by 3. 22.271 kilonewton. This is H1. So we have to substitute into the shear equation. Shear equation R is equal to H1 minus H2. H1 minus H2. H1 is 22.27 minus H2. So it is 2.725. 2725. So we get 22.27 minus 2.725. So we get 19.545 kilonewton. Okay, so finish part 1 of analysis. So the part 1, the last step is until R value. Okay, which we get from shear equation. Okay, remember we have to have table, and from table we have end moment, and from end moment we used to calculate from end moment we used to calculate the shear equation by analyzing diagram like this. So from this diagram, I have divided into 3 steps. Step number 1, step number 2, step number 3 as label. Okay, so we calculate V1 and V2, and then step number 2 we calculate H2, and finally using V1 value, we calculate H1. So once you get H1 and H2, so we just need to substitute into the shear equation. Shear equation is 22.27 minus 2.725, and the R value for table 1 is 19. 0.545. Okay, so inshallah, I will make another video to discuss the second part of analysis, that we will focus to table number 2 and the process, uh, including how to write the shear equation and find uh, the R prime value before we can have in total final end moment, considering both loading as well as sidesway. So thank you very much. We will meet again in the next video, part 2 of this frame. Bye bye and assalamualaikum warahmatullahi wabarakatuh.